Hello, everyone. Welcome to the Data Flowcast. I'm your host, Marc Martin, and today I'm joined by Alexandre Magno Lima Martins, Senior Data Engineer at Teya. And the first thing that I would like to ask you, Alexandre, is how are you doing?
Hey Mark, how are you? Yeah, I'm very happy to be here actually to talk a little bit about what we did in Teya and help foster the Airflow community a little bit.
Aw-
So very happy.
Awesome. I'm very excited because I know that you did a couple of Medium blog posts that are truly amazing, and I can't recommend everyone enough to check out those articles because they're truly amazing to learn how to handle Airflow. I mean, we'll talk about that later in the episode, right? So, just before getting started, I would like to briefly explain the primary takeaways that you will get from this episode. So, you will know how to make Airflow self-serve for users. We will talk a little bit about that. Also, how to generate DAGs based on DBT models. I'm sure that there are many DBT users that are listening to us. And last but not least, some useful tips around optimization and executors. Can you actually start by talking a little bit about your role at Teya and what you do?
Okay, cool. I'm a data engineer at Teya, so I'm more like responsible to build the data platform. Actually, so what we are calling nowadays a data platform engineer. Basically responsible for deploying and like maintaining all our data infrastructure components. So we're related to the extraction of data, storage, and also a transformation of data as well.
Okay. And just to have a better idea of how you run Airflow in your organization, like what kind of use cases do you need to manage today?
Airflow is our primary orchestrator, right? Our main use case, I would say, it's DBT, the orchestration of the DBT project that really powers all the analytics downstream. But also we have a couple of DAGs running that is part of our machine learning initiative, fraud as well, so fraud prevention, and some custom like housekeeping workloads as well that we use to run in Airflow. But the primary use case would be DBT.
DBT. Okay. That's super interesting. And how many teams are working on the Airflow in your organization? Like, do you have many different teams working on it?
Yeah, currently it's being used by the data teams or the teams that relate to data somehow.
Okay.
So it's not just a data engineering team. So we also have like data scientists, machine learning engineers also using it. We want in the future to actually expand this usage to the other engineering teams inside the content. That would be your traditional software engineer that has a use case for some sort of like workload orchestration. But we're not there yet. That's a plan for the future.
Okay. Yeah, it takes time. It takes time. And actually, speaking of that, is there anything that you have achieved or implemented with Airflow that you are really proud of? Because as you said, you have many different teams and at least like profiles that work on your Airflow instance. So I know that you are working on something pretty great. Can you tell us more about that?
Yeah, so I would say that for us, the most exciting thing would be the self-service fashion that we did the whole thing, that we did the whole platform, especially when we talk about our main use case, which is DBT, right? We have a DAG generation pipeline that builds on top of the DBT project. So
Mhm.
when data analysts or even project managers that know a little bit of SQL and can build DBT models, they can see their models being translated into Airflow DAGs, go into Airflow and like run those models as Airflow DAGs without requiring writing the DAGs per se, like without requiring knowing what an Airflow DAG is, right?
Mhm.
Besides like how to trigger it, how to clear a task. So this is also this interaction with the Airflow UI is very important, but they don't need
Mhm.
to know like how to actually write a DAG. They don't need to even know Python.
Wow. So actually, I truly need to know more about that because I know that DAG generation is something that many users struggle with or even wonder how to implement that in their company. So, can you tell us more a little bit about how you generate those DAGs? For example, if I'm a data scientist and I know, as you said, I don't know how to write a DAG in Airflow, um, what should I do with your solution?
Yeah. Yeah. So yeah, our data generation, our DAG generation pipelines more focused on the DBT project. For the
Mm-hmm.
other use cases like data scientists, machine learning engineers, they are usually more comfortable with Python, with the concept of EA DAGs, so they can generate DAGs freely as they basically want to. But of course, we also enforce some guidelines in DAG development in our CI/CD flows. It needs to be tags. It needs to be the DAG needs to have the appropriate tags, a description, the access control layers as well. So we enforce through CI/CD checks a little bit of minimum things that the DAG really needs to have. But when we talk about the DBT project, we have an entirely automated flow of tag generation, right? So we basically read off from the project, we parse the DBT manifest, and we have a separate file that we created that lives inside the DBT project where people can like register their models to be deployed. So they can actually group models however they want. Basically, you can, if you want to deploy a single model, so like a single model becomes a DAG, or you can deploy how many models you want inside a DAG. So you can like slice and dice your DBT project in any way you like, basically.
Mm-hmm.
What usually people do is they separate the project for domains, right? So each DAG, each domain will have its own set of DAGs, what we call model groups. It's like
Mm-hmm.
usually models that need to be run and scheduled together, like that they make sense as a single unit, right? And
Okay.
all the models inside this model group is going to run as a single DAG in Airflow. And inside this DAG, it will follow the normal DBT lineage. So actually the tasks inside the DAG will follow the same DBT lineage for model execution. And we also did that thing that Cosmos did very well as well, which is to split run and test into separate tasks. So every model will run followed by its tests.
Okay. So basically, if I'm a data analyst, I actually don't interact with DAGs directly. I just interact with a file to say that this DBT model should be
Exactly.
should be generated through a DAG, and that's all I did. That's all I do.
That's it. And you also on that file pass like the access control layers and tags and like whatever you want to have a more friendly experience where like when like searching for this DAG you in Airflow. So people can like you actually write the DAG description, you apply tags, and they can determine which roles have access to view and trigger this DAG. So all in this deployment file that we call it.
And this is super interesting. Like this deployment file, what it is it a YAML file? It's a YAML file. Okay, here we go. And so you have a script that goes over those deployment files, or is it a DAG that goes over those deployment files?
Is it a script? Is it actually part of our DAG generation project, right? Because like, this is one thing as well that we needed to consider when starting the project, like how to generate DAGs. And then
Mm-hmm.
of course we have those two methods, which is the single file method or the like
Yes.
multiple file methods, right? So we
Yes.
started with the single file method, but then it didn't work very well because as the DBT project like was growing and more models were added, to actually parse the DBT project at your runtime was like Airflow was like struggling to do that because the manifest gets like bigger and every time we need to read the manifest. So we actually changed that to a multiple file method
Okay.
where the DAGs are generated before pushing it to Airflow. So DAGs are basically generated in CI/CD after merge. So
Okay.
after the checks are like applied and we basically validate. Then we generate all DAGs based off from the DBT project, and then
Mm-hmm.
we push them to a bucket where basically Airflow is just going to read as a normal DAG, right? So we
Okay.
are using these multiple file methods.
That's really amazing. That's really amazing because so you actually saw that using the multi-file method was delivered a better performance than if you were using the single file method. You saw that in actually, how did you see that it didn't work? Did you see that in your
We
metrics or?
were, yes, yeah, we
Oh,
were
okay.
monitoring some Airflow metrics, especially
Mm-hmm.
the bag parse time, like in the scheduler loop time. So
Okay.
we saw that the average scheduler loop time was like increasing a lot as the DBT project was growing, just because like
Interesting.
the manifest was like getting larger, and like in every, so like basically every time that Airflow parses DAG, it had to like run this script that
Mm-hmm.
generates all the DAGs. So you had to parse it all over again. And when we changed to the multiple file method, the scheduler loop time just a lot,
Wow.
and the scheduler itself became more performant.
Wow. And out of curiosity, did you try to tweak some airflow settings first before going to this method, or did you just decide to use the
Well,
multi-file method? And
yeah, one option was to use the separate DAG parser, right? That Airflow has
yes.
to not parse the DAGs using the scheduler, but to have a separate component for that. That could be one option, but we decided to go straight to the multiple file methods because that was the recommended method
Yeah.
for this case. Yeah, we just went straight with it.
Okay. That's amazing to hear because again, some people advocate for the single file method, some people advocate for the other method. At the end of the day, truly, and as you said, you need to look at your metrics, test different things, and see what works best for you and your use case. So that's really good to hear. And just to circle back on the data on the DBT models, I imagine that when you have many DBT models, you had some challenges right along the way to generate those DAGs based on the DBT models. And I know that you have an interesting story about the executor and more specifically the Kubernetes executor. So can you tell us more about the Kubernetes executor, which is an extremely popular
Yeah.
executor, but in your case, why it might not have been the best option?
Yeah, sure. That was a fun one, actually. Oh, yeah. So because like here we run Airflow on Kubernetes, right? So of course our first option would was like to, yeah, let's start by using the Kubernetes executor as we are running in Kubernetes. It's the most logical choice.
Mhm.
And then we started doing that, but what happened was that as our DBT project became larger, we started to have like many tasks. We, of course, because like we orchestrate like more or less on average 2,000 models. So at our peak, we had like over 3,000 models. So you can imagine the
Wow.
number of tasks. If you use the Kubernetes executor, one task equals one pod, right? So you can
Mhm.
imagine the number of pods that we were scheduling per day in our Kubernetes cluster. That's not necessarily the problem. The problem was that our DBT models usually run very fast. They're like usually very short-lived tasks,
Mhm.
right? They run for 1 minute, 2 minutes, and they are done. And we have some peak times that like large groups of models need to actually be scheduled in that same time. So what
Mhm.
happened was that like in some specific moments, we had a large spike in the number of tasks, thus in the
Okay.
number of pods, right? So
Mhm.
our Kubernetes cluster that was running with, like, I don't know, like 100 pods, it blew up to 1,000 pods in a matter of
Okay.
5 minutes. And then what happens that we also, the cloud, the engineering team in our company, they deploy a tool which is called Carpenter, which is a Kubernetes resource management tool. So basically what Carpenter does is that it finds Kubernetes nodes that are underutilized and like reschedule pods on those nodes to actually lower the total the amount of nodes, saving you costs like
Hmm.
at the end of the day, right? And as our tasks were very fast,
Hmm.
you could see that we were like scaling the number of nodes in
Hmm.
the cluster, but like very quickly, those nodes were becoming sub-utilized because all the pods scheduled on those nodes were like
Yes.
being completed. However, some jobs took more than 1 minute or 2 minutes, right? Some
Okay.
jobs were like long living jobs. And what happens that a carpenter, when trying to deschedule those nodes, were like killing those jobs in favor of, I don't know, let me schedule this pod in like the another node. But it was a
Mhm.
running BBT job. It was a problem. It was a problem because we started to have like many jobs being killed because of these spikes in the
Okay.
number of pods and thus in the number of cluster nodes as well. And
Okay.
then to solve that, we decided to migrate to the Celery Executor. So in Celery, we don't have this problem because we have like long living worker nodes. And then they can just like you accept new tasks, right? And those tasks can run very fast. We didn't have this problem when we migrate to Celery.
That's a super interesting story. And actually, so that's a very good point of why the Celery Executor is most of the time better than the Kubernetes Executor. It's because it can run your tasks faster, especially if you have short living tasks. It's much better to use the Celery Executor in this case. But then also a downside of the Celery Executor is that you have some workers waiting, consuming resources while waiting. And so they are actually doing nothing. Have you ever thought of how to fix this maybe issue? Maybe it's not one yet, but have you ever thought of doing something to improve this downside maybe?
Yeah, one way to actually improve that is by using the KEDA autoscaler.
Yeah.
So by using KEDA, you can like scale in or out the number of like salary workers. So in periods that you don't have as many jobs running, you can run with like just one or maybe two workers. But like when you have like more and more tasks being scheduled, you can use that metric, which is the number of tasks in the
Mhm.
queued state, right? To actually as your scale out metric in KEDA. So you like increase the number of workers. So that's a very good way out as well.
Yeah, no, I agree. I agree. Definitely, KEDA is one solution. Also, I heard about, I've never tried it yet, but I heard about the Celery Kubernetes Executor, I believe, which is a mix of both worlds. I know that many people are looking into it. I don't know. Did you look into it yet or?
It's on our backlog. But yeah, we
Yeah.
want to do that as well. That would require a little bit of investigation and testing as well on our side,
Mhm.
on your side because it's a big change, but we know that it can be an improvement. Although like right now when we need to run very custom tasks that would
Mhm.
require a very custom Python packages, usually related to data science or machine learning, we can actually, and we do use the Kubernetes pod operator. So
Yeah.
for those cases, we spin up a totally separate pod to have runtime isolation as well. So we
Okay.
also use it. Yeah.
Yeah, that's a pretty popular operator. Many actually, I don't know if you do that, but many companies have a layer on top of the Kubernetes pod operator so that it defines this layer defines the amount of CPUs or memories and so on based on a use case. So you don't interact with, for example, as a data scientist, I'm not going to interact with the Kubernetes pod operator directly, but I will interact with a custom operator built on top of it. So I don't have control over the resources and so on. Is it something that you are doing or not yet?
That's a very good idea. We don't do that, but it makes a lot of sense because to create this layer of the abstraction, right, on top of
Yes.
the Kubernetes pod operator, it makes a lot of sense. We don't do that just because the use cases that we do need it, they're like very custom, and the people that use it know what they are
Yeah.
doing basically. They're like very comfortable with it.
Good for you. Good for you that they know what they do. Okay, just also very quickly, Because obviously we talked about DBT and generating DAGs using DBT models. Aren't you using Cosmos out of
That's a
curiosity?
ve- that's a very fair question. So our project started like a little bit more than 2 years ago. So
Okay.
at that time, I don't think Cosmos was released. I can be wrong, but if it was released, it was not very popular. So we didn't even consider it as a choice. And as well, because as far as I know, Cosmos doesn't have a way to actually deal with cross-DAG dependencies
Mm.
or cross-DAGs communication. You can split your DBT project into many DAGs using Cosmos as well. However, I don't see how you can connect those DAGs, and that's a thing
Mm.
that was a requirement for us when we started building the project
Okay.
that we are running right now. Because in our case, if one model from DAG A references another model has a dependency on another model that is being scheduled on DAG B, we are going to create a sensor on DAG A
Okay.
to poke for the latest state of the dependent model in DAG B. So we do this activity with sensors.
Okay. I see. I see. I see. Okay, that's good to know, and that might be something that the community will work on for Cosmos to make it better, because that's the kind of feedback that we love to hear. As a final question, what would you most like to see from the development of the Airflow project in the near future? Is there any feature that you would like to see in Airflow in the next release of Airflow? Anything that you would like to see as a new
Mm.
feature or an improvement that will make your life better?
Yeah, like for us, everything that would improve the ability of using Airflow as more like a multi-tenant Airflow, right? More use cases related to more teams using the same Airflow instance. That would be very nice. And ways to deal with it, like one very specific example is the usage of secrets, right? If there is any way of like maybe separating secrets per teams in
Yeah.
Airflow, of course you would need to create the concept of teams or like domains inside Airflow to be able to create a secret per team. So those
Mm.
like minor things that actually, if you want to use Airflow in a multi tenant way, right now you will need to deal with these things yourself. And if it
True.
comes with the next release and the future ones, it would be very good.
Yeah, I agree. I agree. I agree. Definitely, multi-tenancy has been a topic for a while in Airflow, to say the least. Okay, awesome. Thank you for joining, Alexandre. Honestly, it was. I keep saying that, but it was truly amazing.
Yeah.
And what's the best way for folks to get in touch with you if I want to stay in touch with you?
Yeah, I guess LinkedIn would be
Yeah.
the best way. Yeah, just
Okay.
type my name there. You can maybe find it. I don't know. Yeah, LinkedIn would be good. Yeah.
Awesome. Awesome. Thank you again. Thank you for joining the Data Flowcast. Again, it was amazing. We a lot of insights, and thank you so much. Hope you are gonna have a great day, and hope to see you
Thank
soon.
you. I enjoyed very much as well. We thank you, Mark.
Thank you,
Bye
Alexandre.
bye. See you.